last little section deals with oxidation of alcohols. Unlike ketones, aldehydes can be oxidized easily to carboxylic acids. We've seen that type of reaction before. So we can be oxidized more if we have an H connected to that carbon. If you recall, we used Jones reagent to do that. Other types of chemicals can be used also. Silver, so silver oxide with water. That'll selectively oxidize here the aldehyde to the carboxylic acid. Now, silver can be used in another context in a test called Tollens test. It's a really interesting and fun test. It's a test that we use for qualitative analysis often to test whether or not we have the presence of an aldehyde functional group. So the balance reaction is kind of long, but the end result here is that you have an aldehyde with silver under basic conditions. Right? And what you make here is solid silver and the carboxylate ion. So the positive result of this test is that silver precipitates out and it sticks to the glass test tube or flask, whatever you're using, and it makes a silver mirror. It's really beautiful. So if you get a chance, check it out on YouTube. There's lots of cool videos. I'll put a link up to that for our lecture. We have catalytic hydrogenation, and we can selectively reduce if we use Raney nickel. So Raney nickel in the presence of a carbon-carbon double bond and an aldehyde will end up taking away the alkene before it takes away the carbonyl. Right, so if we have one equivalent, that's a 1-to-1 mole ratio, it ends up just reacting at this faster position here. All right. And then the last thing that we are going to look at is deoxygenation. So how do you get rid of the carbonyl? And there's a bunch of ways to do this. So kind of looking at this down below, here's your carbonyl. So you could reduce it with NaBH4 or LAH to make an alcohol. And then we could tosylate and reduce, and that'll make the alkane. The other thing we can do is we can add H2, NH2, potassium hydroxide, and that'll undergo a deoxygenation reaction too. Or lastly, amalgamated zinc. So this is the amalgamated zinc is the one that students really like to use, partly because we've seen it before when we looked at the Clemmensen reduction back in chapter 17. All right, and that concludes chapter 18. Make sure you guys work real hard in this chapter. 18 comes back and we'll see it again with a continuation of reactions of aldehyde and ketones in chapter 22.